Welcome to another deep dive. This time we're going to be exploring the amazing world of biomimetics.
Sounds exciting.
It is. It's basically how engineers are taking inspiration from nature to solve, all sorts of really complex problems.
Right.
And this is going to be super interesting for our listeners because, whether you're really fascinated by the latest in material science, or maybe you're just kind of curious about cutting edge tech, this is the place to be because we've got a ton of cool stuff to go over today. We've got academic papers, we've got some overviews, and some really, really cool real world examples that we're going to unpack today.
It's amazing to think that nature has had like millions of years to perfect its designs, through evolution.
Yeah,
And we're finally starting to tap into that knowledge.
it's true. And you know what I mean? It's like, think about how long creatures like geckos have been like defying gravity.
Right.
It's not magic.
Yeah.
It's science.
Yeah.
And science can learn a lot from nature's innovation.
Absolutely. And, a great example of that is those tiny hairs on gecko feet. They're called setae.
Okay.
And they create so much surface area that they can actually stick to almost anything.
Really?
Yeah. And what's even more impressive is that this adhesive power is also self-cleaning.
Oh, wow.
It's huge for fields like robotics where, contamination can be a real issue.
Right. So we're talking about robots that can like climb walls like geckos.
Exactly.
That's awesome.
Yeah.
What other kind of design tricks has nature come up with?
Well, let's move from dry adhesives to wet adhesives.
Okay.
Believe it or not, salamander mucus is incredibly effective as a biocompatible and antibacterial adhesive.
Salamander mucus. I never would have thought of that.
Yeah.
Where can we even use something like that?
Well, think about applications in surgery.
Oh,
Or even underwater construction where traditional adhesives just won't work.
that's amazing.
Yeah.
So nature's giving us this whole new toolkit for sticking things together. But how about keeping things fresh?
Okay.
I'm always battling wilted lettuce and stale bread.
Oh, yeah. I hear you on that one. Well, imagine coating food packaging with a material that mimics the water-repelling surface of a lotus leaf. Water just beads up and rolls right off.
So no more soggy sandwiches.
Exactly. No more condensation in the bag.
Sign me up.
It's not just about water resistance, though. Nature has some clever ways of fighting bacteria, too.
Really?
Yeah. Insect wings, for example, have tiny structures that can actually puncture and kill bacteria.
Right.
And gecko skin actually has properties that disrupt microbial growth.
It sounds like we're on the verge of having food packaging that's not only biodegradable, but also like actively helps keep food fresh.
That's the goal. And there are some really interesting innovations already happening.
Oh, yeah.
Yeah, researchers are looking at things like a composite material inspired by pomelo peel.
Pomelo peel.
Yeah, that's strong antibacterial, and it even helps control moisture levels.
That's incredible. It seems like nature has the solution for everything if we just know where to look.
Right.
But what about challenges that go beyond food storage? What about medical applications?
That's a great question. Bioimplants are a huge area of research right now.
Okay.
They're developing 3D printed materials that mimic the structure and properties of real bone,
Oh, wow.
which could lead to implants that are less likely to be rejected by the body.
That's amazing. So they're essentially creating artificial bones that the body can actually accept.
In a way, yes. And it goes beyond just bones.
Okay.
They're also working on multi-layered polymers that are designed to mimic the structure and function of heart tissue.
So we're talking about longer lasting, more compatible heart implants.
Exactly.
It could be revolutionary for so many people.
Yeah.
But we've been talking a lot about materials. What about movement?
Yeah,
Can nature teach us anything about how to build like better robots?
absolutely.
Yeah.
The field of soft robotics is all about taking inspiration from the flexibility and adaptability of creatures like octopuses and starfish.
Yeah, they can move in such fluid and graceful ways. It's mesmerizing.
Researchers are working on creating artificial muscles that respond to things like temperature or electricity, which could lead to robots that move with more nuance and precision.
So instead of clunky, jerky robots, we could have robots that can like gently pick up a strawberry without crushing it.
Exactly, or perform delicate surgical procedures.
That's incredible. The possibilities are pretty amazing. But of course, as with any emerging technology, there are challenges to overcome.
Right.
Nature's designs are often incredibly complex, and it's not always easy to replicate those structures and processes using our current manufacturing methods.
That's true.
And it sounds like biomimetics requires a lot of collaboration between different fields, too, right?
Definitely.
You need biologists to understand the natural systems, and then engineers to design the solutions, and material scientists to create the right materials.
It's inherently interdisciplinary.
Yeah. bringing together experts from so many different fields can be challenging.
Mm-hmm.
But that's also where the real breakthroughs happen, right?
Absolutely.
So it's not just about like copying nature, it's about truly understanding its principles and working together to apply those lessons in creative and innovative ways.
Exactly. And it's important to remember that this is a rapidly evolving field.
Yeah.
New discoveries are being made all the time, which means that the potential for biomimetics to revolutionize various industries is constantly growing.
It's mind-boggling to think about all the possibilities. What are some of the areas that you're most excited about for the future of biomimetics?
Well, one area that I find particularly fascinating is the development of more sustainable and eco-friendly solutions.
Okay.
Nature is inherently sustainable, and by learning from its designs, we can create technologies and products that have a lower impact on the environment.
Right. It's not just about creating cool new gadgets. It's about finding ways to live more harmoniously with the planet.
Absolutely.
So what are some examples of how biomimetics is being used to create a more sustainable future?
Well, we've already talked about biomimetic food packaging that can help reduce food waste,
Right.
but researchers are also looking at ways to mimic the energy efficiency of natural systems like photosynthesis to develop new renewable energy sources.
That would be a game changer. What other natural processes are they looking at?
Well, they're also studying the self-healing properties of certain organisms to create materials that can repair themselves,
Oh, wow.
which could drastically reduce waste and extend the lifespan of products.
That's incredible. It seems like nature is offering us a blueprint for a better future. But before we get too carried away with our bio-inspired dreams, maybe we should pause here for a moment.
Good idea.
And when we come back, we'll delve into some of the more cutting-edge and even futuristic applications of biomimetics.
We'll be talking about things like nano and microfabrication,
Ooh.
energy harvesting inspired by electric eels, and even biomimetic drugs and nanorobots.
It's going to get really interesting.
Good tune.
See you in a bit.
Mm.
Welcome back. Last time we were talking about some pretty amazing things like self-healing materials and robots that could work in all sorts of crazy environments.
Yeah, it's amazing what nature can do.
It really is. Where do we even go from there?
Well, how about shrinking things down to the nanoscale? Nature is a master of working at incredibly tiny levels.
Okay, we're talking really small now.
Yeah.
But how does that relate to biomimetics?
Well, think about the properties of certain surfaces in nature, like the lotus leaf.
Okay.
Its ability to repel water comes from the way its surface is structured at the microscopic level.
So are we talking about like recreating those tiny structures to create new materials with amazing properties?
Exactly.
Right.
Using techniques like nanoimprint lithography, scientists can essentially stamp those patterns onto surfaces.
Wow.
Imagine fabrics that never get wet or paints that change color with the light.
Those are some cool applications.
Yeah.
But could we also create things that are stronger and lighter, like spider silk?
Scientists are working on that too. It's a challenge to replicate the incredible strength and flexibility of spider silk.
Yeah.
But by using techniques like layer by layer assembly, they're getting closer all the time.
It's fascinating to think that we can learn so much from creatures as small as spiders.
It really is.
So we've talked about materials, but what about energy? Can nature teach us anything about how to power our future?
Well, imagine if we could harness energy from sunlight the same way plants do through photosynthesis.
Artificial photosynthesis.
Yeah.
Is that even possible?
It's definitely an area of active research. Scientists are making progress in developing artificial systems that can capture sunlight and convert it into usable energy.
Wow, that would truly be revolutionary for renewable energy.
Yeah.
What other natural energy sources are scientists exploring?
Well, some organisms generate electricity in other ways. Electric eels, for example, use specialized cells to create powerful shocks.
Yeah.
And researchers are looking into piezoelectric materials, which generate electricity when they're subjected to pressure or stress,
Oh, interesting.
inspired by creatures like electric eels.
So instead of relying on traditional power sources, we could potentially generate electricity from movement or vibrations.
Exactly. Think about sidewalks that generate power from footsteps or buildings that harness energy from the wind.
It's a whole new way of thinking about energy. But let's not forget about the field of medicine. Are there any bio-inspired breakthroughs happening there?
Absolutely. For instance, researchers are looking at how to create biomimetic drugs,
Okay.
essentially medicines inspired by the healing power of nature.
So we're talking about medications modeled after the compounds found in plants and other organisms.
That's the idea. They're also exploring wound dressings inspired by spider silk, which has natural antimicrobial properties.
It's like nature already has solutions for so many of our problems. We just need to figure out how to unlock them.
That's a great way to put it.
But with all this complexity, how do we even begin to unravel nature's secrets?
That's where AI and machine learning come in. Think of them as powerful tools for analyzing the incredibly intricate structures and processes we find in nature.
So AI can help us understand and decode nature's designs.
Exactly. By identifying patterns and insights that might be missed by the human eye, AI can accelerate the development of biomimetic solutions. And it's not just about analysis. AI can also be used to simulate natural systems, giving scientists a virtual testing ground for their ideas.
It sounds like AI is an indispensable partner in the field of biomimetics.
I think so.
But with all this talk about mimicking nature, are there any ethical considerations we need to be aware of?
That's an important question. One key distinction is between biomimicry and bioutilization.
Okay.
Biomimicry is about drawing inspiration from nature, like we've been discussing, without actually using biological materials.
It's like designing an airplane inspired by a bird's wing without actually using feathers.
Precisely. Bioutilization, on the other hand, involves using biological materials directly, like harvesting spider silk, for example.
Okay.
And that can raise concerns about sustainability and the potential impact on ecosystems.
So while we're learning from nature, we also need to be mindful of how we interact with it. We don't want to harm the very systems that are inspiring us.
Exactly. And we need to have open discussions about how to develop and use these technologies responsibly, considering both the benefits and potential risks.
It's a reminder that biomimetics is not just about technological advancement. It's also about ethical responsibility.
Well said. And I think this leads perfectly into our next topic, how nature has adapted to some of the most extreme environments on Earth.
Now, this is where it gets really interesting. Let's dive into the world of extreme survivors.
Let's start by plunging into the deep sea. Think about a world with crushing pressure, freezing temperatures, and no sunlight. And yet life not only exists there, it thrives.
It's mind-blowing. What kind of creatures can survive in an environment like that?
We'll take the anglerfish, for example. It uses a bioluminescent lure to attract prey in the pitch-black depths. And then there are the deep-sea corals that build intricate structures despite the immense pressure.
So what can we learn from these deep-sea dwellers?
Their adaptations could inspire the development of new materials that can withstand extreme conditions. They could also lead to breakthroughs in low-light imaging and sensing technologies, which could be incredibly useful for exploration and underwater construction.
That's fascinating. What other extreme environments could hold biomimetic inspiration?
Well, think about the scorching deserts. Cacti are masters of water conservation, surviving for years in some of the driest conditions on Earth.
They've certainly got that figured out. How do they do it?
They have incredibly efficient systems for collecting and storing water. Their spines provide shade and help condense moisture from the air, and their shallow, widespread roots allow them to quickly absorb any rainfall.
So what kind of biomimetic applications could come from studying cacti?
Their adaptations could lead to innovative designs for water harvesting systems, drought-resistant crops, and even building materials that can regulate temperature and humidity in arid climates.
That could be revolutionary for regions facing water scarcity. What about the other end of the temperature spectrum? What can we learn from the icy polar regions?
Think about penguins, for example. Their tightly packed feathers trap air, providing incredible insulation, and their blubber layer offers additional warmth. And then there are polar bears with their thick fur coats and streamlined bodies that are perfectly adapted for swimming in icy water.
They're both incredible examples of adaptation to extreme cold. What kind of bio-inspired innovations could come from studying them?
Their adaptations could lead to advancements in insulation materials, cold weather gear, and even more efficient designs for ships and submarines.
It's amazing how nature has found ways to thrive in such a wide range of environments. It really does feel like there's no limit to what we can learn from the natural world.
I completely agree. And as we face increasingly complex challenges in the 21st century, biomimetics offers a powerful and inspiring approach to finding solutions.
It seems like nature is offering us a roadmap to a more sustainable, resilient, and innovative future. But I think we've covered a lot of ground today. Should we maybe take a moment to process all this incredible information before we wrap things up?
Sounds good to me. When we come back, we'll share some final thoughts and takeaways from our deep dive into biomimetics.
See you in a bit. Welcome back to the deep dive. It feels like we've gone everywhere in this episode. From like the microscopic world of gecko feet to the, vast depths of the ocean,
It has been quite a journey.
exploring all these ways that nature is inspiring some really remarkable innovations.
It's true. We've seen how nature has already solved so many of the challenges that we're facing today.
Mm.
Things like creating strong and lightweight materials and developing, incredibly efficient energy sources.
And what's so exciting is that we're really just scratching the surface here. As our understanding of the natural world grows and our, technological capabilities advance, the potential for biomimicry to really shape our future is only going to increase.
Oh, absolutely. I think one of the biggest takeaways from our deep dive here is that biomimicry is so much more than just a collection of, cool examples.
Yeah.
It's really a fundamentally new way of thinking about design and problem solving.
It's like we're shifting our perspective from, one of dominating nature to one of learning from it,
Right.
recognizing that nature has already spent millions of years perfecting these designs.
And it's not about just copying nature blindly either.
Yeah.
It's about understanding the underlying principles behind those designs and then adapting them to our own unique needs and challenges.
It's about collaboration between different fields, thinking outside the box and being open to inspiration from the most unexpected sources.
Exactly. And as we've seen today, the potential applications are vast,
It's true.
spanning across industries from medicine and robotics to energy and sustainability.
So what does this all mean for the future? Where do we even go from here?
Well, I believe the future of biomimicry is incredibly bright. As we delve deeper into the, intricacies of the natural world and as our technological capabilities continue to evolve, we're going to unlock even more innovative and impactful bio-inspired solutions.
It really feels like we're standing at the dawn of a bio-inspired revolution.
I think so.
And I, for one, am incredibly excited to see what we can achieve by tapping into nature's, 3.8 billion years of research and development.
Me too. And I hope that this deep dive has inspired you to look at the natural world with a renewed sense of wonder and possibility.
Absolutely. So to all our listeners out there, the next time you find yourself admiring a spiderweb glistening with dew, or a bird soaring effortlessly through the sky, or even just a simple leak unfurling in the sunlight, take a moment to appreciate the incredible engineering feats behind those natural wonders.
And ask yourself, what problem could that natural phenomenon help us solve? What secrets does it hold that could inspire the next groundbreaking innovation?
Because the future is bio-inspired, and the solutions to some of humanity's greatest challenges might just be waiting for us out there in the natural world.
All we have to do is look closely and listen carefully.
That's it for our deep dive into biomimetics. Until next time, keep exploring, keep learning, and keep asking questions.